Okay, good afternoon, everyone. Welcome to day 6 of our AI ML for Developers Bootcamp. It is a great pleasure to have you guys again today. We've been here from day 1 and we've been riding on strong till day 6. Honestly, you guys' resilience is very encouraging, honestly, and thank you for being here once again. Today we would have another class and would have Mr. Nehemiah as usual, our instructor, take us on this class. So without further ado, I would be making some more what's it called at the end of the class, some more announcement at the end of the class. So let's just allow Mr. Nehemiah to take over now. Mr. Nehemiah, there's a question in the comment section. You can begin with that question before getting into today's class. Hi, Mr. Nehemiah. I'm asking you to unmute from your end now. You should please kindly unmute and speak.
All right, thank you so much. Are you able to hear me? You can hear me? Hello?
I can hear you loud and clear.
All right, thank you so much, Aisha, and I hope everyone is doing well wherever you are. And yeah, I'm very glad, you guys, to have you on board. So the question that someone has asked in the comment, are we going to submit the assignment as a notebook file? Yeah, make sure that you're submitting this in this format. Like where you've written your assignment, like I just submitted that file. Save that file and submit it the way it is, so that I can just run the code and see how you did it. So it should be in the notebook file, which is .ipynb. So that's the extension for the notebook files. So make sure that the working or where you're working, you just submit it the way it is, like that file where you're working on. Yeah. All right, great. So let me share the screen so that we can begin straight away. And sorry, we didn't have a class yesterday. I had the power issue. Are you able to see the screen? Okay.
Your screen is coming up. I'll let you know. Yeah, we can see the screen now.
All right. Thank you so much. All right. So today we are going to learn about functions, and just remind ourselves. I told you at the intro that in any programming language, like there are some key things that you need always to know, so that you can master that language very well. I said, first of all, to understand how variables are used in that language. The second thing I talk about the data structure. And you remember, I think the other day, we said like Python like has, like we have different data structures. Like for example, if you're using the list, you saw the characteristics of a list. Like this one is changeable. It is ordered. It is also yeah, it's ordered. It is, and then also it's defined with the square brackets, and then it allows the duplicates and so forth. And also for the tuples, we say that this one is ordered but unchangeable. And then also we say that it also allows the duplicates, and it's defined with the rounded brackets. And then for the sets, we say that it does not allow the duplicates. It is unordered, and it's unordered. It does not allow the duplicates defined with the curly braces. Similar to the dictionary, it's also defined with the curly braces, but I stress that in the key value pair. It is ordered, but then you cannot access the elements with their index number because it takes the keys. So you access the elements with their keys, not the index, but it is ordered. So those are the key things that you need to consider or maybe know in data structures, because you'll be able to understand how you will deal with values or data values in that case. And then now we are talking about now the functions. I said also this is also very, very key. And we shall also later talk about the classes, especially Python, I said, is an object-oriented programming. So we'll talk about that one as well. So previously we've been talking about, so let me open the last file. So last time we had this list, and I remember now the advantage of using the notebook, like you're able to split codes, like a codes in cells. Like I can see here, I have this first cell which is handling this stuff. Then this other section. But then sometimes you might be writing like your Python programs like in just one line, like one file. Perhaps you won't be using this notebook. Let's say you just have a .py file, which is just a plain file, doesn't have like a this cell like in the notebook. So, and how usually Python works, it usually executes codes line by line. For example, let's say you are interested, for example, to only get the output here. For example, whatever number here it is, you wanted to get the output for this one. So for example, if it were just a normal file without these cells, like it wasn't a notebook file, then it's going to mean that a Python is going to execute code line by line from here, from the very top until the very bottom for you to get the output where you are intended. In the past, maybe in your code, you could be having, for example, the error, and when Python finds those errors, then it's going to stop like execution, and then you debug it so that it can continue, because it's going to execute line by line until it reaches the very end. So you'll notice that, for example, you're only interested in some specific parts, but then you have to do what you have to run like everything from the very top. And you cannot, that is time consuming, and then it's also going to take resources. It's going to take like your system resources. And that's why a function is very, very key, because a function in Python can only be executed once once you call it. Like you can have as many as you want, but then it's going to be executed the moment you do it, the moment you call it. For example, you can have like a program like let's say, so basically Python functions are defined with the def keyword. They are defined with the def keyword. But they guys remind me, after this Python, I should talk about the conditional statements. I should have begun with that, conditional statements and the loops. But then because I've begun with Python, in case I forget, remind me after I finish functions to talk about that one. But then functions are defined with this def keyword. Then your function name, your function name. Remember, this is just a placeholder. It could be now your real name for that function. For example, if you want to have a program to do the arithmetic or maybe some basic addition, you could call your function, for example, addition or something like that. Like you want to use like descriptive names for your function. So this is the syntax on how you write your Python function. You first of all begin with the def keyword space, then your function name, followed by the parentheses and then the colon. Then after that, like anything that you want it to be executed within that function now should be here. So let me just say you write your program here. So in this case, for example, anything that you're going to write here, and then you run them, it's not going to be executed unless you call these functions. So let's demonstrate with one example. This one is incomplete. First of all, if you want to know this error, you can use the pass keyword. Like this, just to ignore the error. But then let's try to demonstrate to work with one. So here I'm going to use def keyword, and then the function name I'm going to call it for example, just addition. Addition, I said that it's defined with the parentheses followed by the colon, and then anything that you want to write within that function now should be within this indentation block. When we were talking about the Python syntax at the intro, we said that it's sensitive to matters indentation. So for example, if you're using the functions or the loops, the conditional statements or the loops, like anything that I want it to be in that condition. For example, if it is a function, anything that you want to fall under that function, then it should be within this indentation block. And it's mostly recommended to use the tab. Tab is like a 4 space. So you're going to click 1, 2, 3, 4 to create the space, or you could just click tab on your keyboard, then it's going to create. But if you follow this step by step, when you just click here, it's going to automatically create for you the indentation. And then remember we've been using mostly print statement. For example, we wanted to get, for example, 100 plus 100, and then we were getting the output. But then remember that this you could as well, like a print statement is mostly used when you want to debug. Maybe when you want to debug, but I know, for example, in production, perhaps you'll be working with the APIs, or maybe the response you want to return in the JSON like document. And for example, you have this application that has your, your models and all that. But then, like I want that application or maybe your programs to be accessed in a different application. So because this one is only used on the debugging or maybe just to get the output here at the console, it's not going to be useful. So Python provides another program to do to get us like the output, which is a return statement. We are going to talk about that one in a few. But then, for example, if I want to get now the output, now let me try to run. When I run, you can see nothing is going to happen. Nothing is going to happen. Perhaps let me try to create several. And then the other one, perhaps I could call it subtraction. I'm not sure if this is spelling, subtraction. And then the other one is division. A division. And then this other one, we can call it multiplication. Multiplication. So here I'll just change it to perhaps subtraction. I could use minus. Then a division, I could use this /, and then a division. Okay, multiplication I'll use asterisk. So now you can see when I run this code, like nothing is going to happen. Although I've written like a mini code, but nothing is going to happen. Nothing is going to happen. So this now the usefulness of this one. Like for example, let's say you're only interested in this multiplication. I could use a different cell. Let me use a different cell, but remember when you run this cell, it is still in the memory. Even if you use it in a different cell, it will still remember what you've written here. So let me just use to organize the work well. Let me use a different cell. Now to call a function, you are going to use the same function name that you created the function with, followed by the parentheses. Now, if you don't have any parameter here or arguments, then I just use the rounded brackets. You remember I told you in the intro that functions are always defined with the parentheses. Parentheses, or for example, when you use something like a print function, it must have those parentheses, and if it has any argument, you need to pass in the inside. And then also the methods. Methods, these are functions, but these are functions which are used inside that class. We'll talk about it in a few. So now, when I call this multiplication, when I just cite this multiplication, the same function, followed by these parentheses, then this is when I'm going to get the output. So you can see now, it's only executing the parts that I was interested with. It's not like trying to do it, like to execute these other codes. Like we've written a lot of programs, but at the output, we're only interested perhaps in this multiplication this time. So you'll be just calling that part. So you can see this one is going to be very, very useful. For example, if you have like a many lines of code, but then you don't want to like execute everything for you to get like the final output where you are interested in. So you can write like many of them, but then you'll be calling just where you are interested in. So this now how the function are very, very useful. And then they are also reusable. Like this function are very, very reusable. Like we are going to talk about arguments in a few, but when we talk about the arguments, you could like give different values or maybe arguments to a function such that you could get different output using the same functions. You remember in variables, we said it's dynamic. For example, when you say A, and then you give it 100, then you say again A, you give it 200. So when you say print A, it's going to use the latest, like these are 200. So it's going to ignore this A. But then now with functions, you're able to use the same function, but then you give it different arguments, like you give it different output, and it's going to just do the same thing. So before I talk about the arguments, is everything clear on the function definition? Or maybe the function syntax? I said that first of all, you begin with a def keyword, then your function name, followed by the parentheses, then at the colon, make sure that you have the colon, and then anything that you want it to be under the function, it should be within this indentation block. This in the like indentation is like at the space from the start to where your first character is. So this space is the indentation block. So we are creating this indentation like to show that the code that you are trying to write is under this function block. When you begin it in a new line, then it means that's not part of this function. But then if I want to tell it's part of this function, then after this colon, it should be within this indentation block. So this is the syntax. And I remember, there's nothing different here. Like the way we've been writing like our list, the programs in the list, the only difference that are here, we are writing here in this indentation block, but everything is just the same, only that we are using the function to execute those codes. Like instead of like running like manually, like this way, we only we are adding those programs here within the functions. For example, you could say sometimes, for example, you create a variable a variable another one. Okay, let's try. Let's say a we give it a value like a 10. Remember how we are just getting the normal variables. Then a b we give it, for example, 30. Then here you could say, for example, a multiplied by b. So when you run this one to be in the memory, then when you call this one, when you run this one, you can see you're going to get the output. So it's just something similar to how we were writing like normally our variables, only that now this one is within this function block. This within this function, such that when you want to execute this function, like it's going to only call this part, like execute the codes within this function block. Is that part of the syntax clear? Okay, I see people are saying that it's okay, and that's fine. All right, so there's also a very, very important thing that you need to understand about the functions. They are called arguments. So arguments are very, very useful, and we are going to demonstrate one in a few, because the essence of functions is to make your work easy and reusable. Like I want, for example, if you have a function, like you can tell, for example, something like the print function. The print function you can use, for example, to run the integers, you can run the integers, you can run the floating point numbers, or maybe strings, or whatever it is. So you can see it can be reused like in different case, like it is reusable like in different context. So that's the importance of arguments. So arguments like these are information that we are going to pass alongside the function definition. So for example, let's just use addition. So we are going to define the function with the def keyword, and then the function we could call it addition. Then we say that it must be within this, what do you call it, like parentheses, then followed by the colon. And then here you can write what your programs. And then this time we're going to use the return. Remember, return and print, they are all used to like return the output, or maybe to return the output. But then now the print statement, this one is restricted to the terminal, or maybe to this console, like just here now. But then for the return statement, this one you can return like a JSON response. You can write, return also the HTTP responses, or whatever kind of response it is. Sometimes you want to like send data in a different, in a different application. You're using the APIs, but then you cannot use that print, because this one is only restricted on the console, like on that output where you're using. But then our return statement is similar to this one, but then now the advantage is that you can use it to return like any kind of response. But then it's still the same thing. So in this case, I'm going to use, for example, A, and then, for example, multiply by B. But then this A and B, I don't want to use it as a variable, because if I use it as a variable, for example, if I want to give it a new value, like you can see here, if I want to, for example, to get a new value, B a new value, then it means that I'll have to go back to my function, and then I reassign the new value. So if that were the case, for example, if we wanted to like execute in a normal print statement, for example, if we wanted to execute, for example, a string, initially perhaps you are running an integer, then it means that I will need to go back to the print function where it was defined, then I change the code so that we can reuse it. So you can tell that it won't be effective, like because the essence of the function is to make it be reusable. Instead of going back to the function, you can just give it new arguments. So the information that you're going to pass here, they are called parameters, and then the values that will be given it will be arguments. You can call it, I use an example when we are talking about the variables, when someone tells you get me a cup of coffee, they don't mean that you give them an empty cup for coffee. They mean that you give them both the cup that contains the coffee, or maybe if someone tells you I want coffee, you'll not give them a coffee hanging in the air. You need to store them somewhere. So they literally mean the same. So parameters or arguments, they are literally the same. But in this context, in the function context, you can call the information that you're going to pass here is variables. You can call them parameters. So when you say, for example, A and B, these are going to be considered as parameters. And then now the values that you are going to assign to these A and B, and they are now arguments. So in this case, we have what we have A and B is our parameters here. Now the values that we are going to call, okay, let me run. So you can see now nothing is going to be executed. And then now when I try to run try to run this code like this, I'm getting this error. I'm getting this error that addition are missing two required positional arguments, A and B. It is missing, you can see here, we have defined the function with two parameters here. So it's going to expect two arguments, to represent A and B when you are trying to call that function, because now it's no longer empty this other one. This one, we define it without anything. But then in this case, we are defining now the function, but then we are adding now parameters in the inside. So when you're adding these parameters in the inside, then when you'll be calling the function, to call the functions, you're trying to use the same function name, and then you use the parentheses, similar to how you could call the print. For example, you just type print, and then you pass in the information that you want to execute here. So it must be within this parentheses. So we're trying to create our custom function now in this case. So you're going to call this function the same way you define. But then remember, when you're calling the function, should be within the new line. Should be within the new line. It shouldn't be within that indentation block. Otherwise, it will be trying to call it will be trying to call itself recursively. So I make sure that it should be in the new line. Now, in this case, because when you run without passing the information for A, remember, they are going to act as variables. You remember variables when you say, we said that variables in Python are created as soon as you assign a value to it. So if you do not assign a value to a variable, then it automatically means that it's not a variable. When you say here X, when you say here, or maybe let's say print X, when you say print X here, it's going to tell me it's not defined. Or maybe when I just say, for example, X here, then I run, I'm going to get a X, it is not defined. But then when I assign a value to it, then it's going to be a variable. When I assign a value to it, then you can see I'm not getting an error, because now this is a full variable, because we have done what we have assigned a value to it. So the same case it is here. So this A that we've created here, these are variables we are creating. But then we call it, in function, we call them parameters. We are calling them parameters. These are things that we are passing here. They are considered as variables, but then we call them, in function, we call them parameters. So these are the variables we are creating, or parameters, and then this is where you want to use those variables or those parameters. Now, we need to give it information, like A to represent what, how you could say X to represent this value 10. So on the function call, you need to add in those values. For example, you want A to represent what? For example, if you want A to represent 10, and then a B to represent 30. So in this case, A is going to be position, it is a positional argument for, this 10 is a positional argument for parameter A. So it is position where there's A, it's going to be in that format, A has begun, which means that the value that you are going to give it first is going to be to represent A, then a B, like that. So it is positional. When you're calling it, make sure that you give it the same number of values. So when I run, then you can see now it's getting, we are getting the output. We are getting the output. And to explain something that I was talking about earlier, that the goodness of working with the function, they are reusable. They are like reusable components. So I can still have the same function, but then I want to use what? I want to use different values. For example, I want to use 50, and then, for example, here I use 70. So you can see, okay. Okay, there's something that, let me run this one first, and then, All right, so let me use a different cells. Let me use a different cells. First of all, we have that. So the first one, we're trying to call the function with these 50 and 70. Okay, let me see. And then similar, we are trying to call the function with these are 10 and 30. So we are trying to do what we're trying to use the same function, but then with different values. It's different, like it is totally different. These arguments are totally. But then I was expecting it to run here. I wanted it to run on the same on these are same on the same cell, but then it seems it is not working. But then now the essence is that these things are reusable. Like you can use it with different arguments. Like I can see when you call it with different values, so you don't need to go back to the function and assign values to variables. Like you can just call a function with the new arguments, and you'll be using it that way. So you don't have to go back to the function and add in the change the variables or values there. You just pass a new information or new arguments. So this information that we are passing here, the arguments for this parameters here at the top. They are this, you can call these variables. In the variable case, you call these variables, and then this now the values for variables. But then in function, you call these parameters, and then these are arguments. Like the information you're passing for the addition. But then then don't make this it can be used in either way. Sometimes you could call these arguments, or you can call either of those arguments, because they're still there information that are being passed within a function. Because when I say that, when you say get me a cup of coffee, and then someone says you get me coffee, they are literally meaning the same thing. So when you say, for example, these are just containers for storing these values. So they are literally the same thing. So if you call them arguments, so it's still no problem, because still they are values that you are passing within a functions within a function. Yeah. So basically these are arguments. Let me know, guys, if it's clear, if you've understood the arguments.
Let's use the comment section. Yes, please.
All right, I see. People have understood. Yeah. Now, now you notice something about this function. It is working well because it is position. Like in this case, it's position. Let me try to remove something here so that it can be somewhat small, or maybe easily accessible. So these are positional because here we used two variables. Here need to or a parameters. Here I'm calling it with two arguments. That's why it's working. But then when I introduce another value here, for example, 70, then I'll be able to do it. I'll get an error that addition takes two positional argument, but then three were given. So in this case, because it's a positional, when you use more or less, let's try with less, perhaps 10, still you get an error that it's missing one required positional argument, B. So whenever you're using the positional argument, you need to do what you need to specify. You need to also give it the same number of values or arguments when you be calling the function. If you've used here two variables, you need to assign it to values to these arguments or parameters here for it to work. Now, sometimes you are not sure about the number of arguments, because we say that this function should be reusable. And sometimes you have modules. You have modules like modules. These are like code libraries, which are written somewhere in a different files. And then you import that file. Then you use that code in a separate file, because sometimes you don't want like to write a program that has perhaps more than 2,000 lines of code. Like it's going to be very hard to manage that code. So what you'll do, you'll split like your code in like small portions. And then, for example, if you want to use the code from a different file, you just import that file with the code, and then use that in a separate file. And then you'll not want to go there and check the number of arguments, know how it was structured, positions, for you to be able to do it, to know how you will be calling the functions. So there's something called the arbitrary. Arbitrary is something like a known, right? Arbitrary is something that is a known, like it takes any number of arguments. So for example, let's say you have children. Let's create a function called children. Children. So this is a function called children. But then let's assume that, for example, I have 6 kids. You might be having 2 kids. Another person could be having, for example, 12 kids. And I will want like all these people, me, you, and the other one, to use the same function. And I will say that it's positional. For example, when it's positional, like you need to, for example, if I have 6 children and I have like a design, or maybe created a function to only work for 6 people, then when another person will be using, and then perhaps their children their children are perhaps 2, they will get that error that we saw earlier, the positional arguments. So in that case, we need to like have an arbitrary arguments, which means that it can take any number of arguments. So basically, the key, the syntax for arbitrary argument is star, and then like this, star, and then this args. So the what do you call it, the syntax? Remember these args, like it's like anything, like this, they are just argument, like they are just variables represent variables, so it could be anything. So you begin with star, and then these args could be any name. For example, let's call it kids. So you have to begin with the star to show that it's arbitrary, and then your variable, or maybe your parameter here, or you could call it argument. But then arguments will refer to the values that are being passed on a function. So basically, there are those values. But if you call it argument still, it's not fine. If you couldn't remember the parameters, still referring to the same thing. So now in this case, for example, let's try to print or a return. Let me use return, because it literally means the same. For me, I always like working with a return whenever I'm using the functions. So return, and then I'm going to use a formatted string. Basically, a string, remember we said that strings are usually defined with we call it them what, like the quotes, But then within this, when you use it within the quotes, like you're not to be able to pass like a variable within a string. For example, let me demonstrate with a different example. For example, let's say we have a, we are giving it a value like 100. Remember, when you print a, it should do what it should return, for example, that value of a. So it's like a container for a value 100. So let's say another part, perhaps we wanted, for example, B, to utilize this A. For example, you want to use a string, and then, for example, let's say I bought it at A. So you wanted, for example, to use this A as a variable, like this A to be a variable. Like when you are calling the function, it's going to like give you the output. But then when you pass now here B, because our intention, our thoughts was like this A to be a container for value 100. But then when you run, we are getting it as a normal string. So basically, like to avoid like getting this what do you call it, like this normal text, Python provided a way on how you can format your string such that you can use variable inside it. So to format a string, you can use the small f or capital F before your string. So you just like your string normally, but then you're going to begin with F before the start quote. And then now where you want to have your variable, you're going to pass things like sets, like something like this. You're going to pass like you're going to wrap like that text, like that text to be in this curly braces. Then you pass now your variable such that you get now the value 100. So it in this case we have done what we have formatted this and these text so that we can use variable within that that string. And I think you've ever maybe enrolled to a particular platform, and then for example once you've signed in to that platform, you will see that for example welcome, then your name. For example, the name that I used for example to enroll to that system is going to say, for example, hello Nehemiah, welcome to this website or whatever it is. So like it doesn't mean like we have people who have hard coded your names, who have hard coded the names. For example, if it's a system that has, for example, a million user, so we'll not have like those many developers. We'll be hard coding like portals for different different people. So basically, you will be having, for example, a text, normal text, for example, hello, but then now that part of the name you are fetching, for example, from the backend, like from the database. So you'll have just your normal text, for example, hello or a greetings, greetings, and then a name, that part of the name, because I want it to display dynamically for different people. So you'll be using something like this, such that that part is like a placeholder, like using these curly braces, so that this information will be fetched from somewhere, perhaps normally from user input, or maybe just a normal variable, or maybe from an API, or maybe just from the database. So you could store like a variable. Remember, variable can store and data from anywhere. Could be, for example, from the user input, or just directly, or maybe from the APS, or whatever it is, wherever it is. But then, so this one allows you like to display data, within the string. So I'm trying to use the same thing here in this return statement. So I'm going to say, for example, my first born is, and then in this case, I will need to specify. Now I'm using these curly braces, but then I remember when you'll be calling the function arbitrary arguments here, you need to do it. You need to pass it this way, the kids, and then it will specify now the position, the index. For example, let's say you want like the first index to be for the firstborn. So in this case, when you'll be calling this function, let me create a new. Let me see. Okay, yeah. So now let me try to call this function with only one argument. First of all, when I run this way, okay, where was I? When I run here without like any argument. So when I specify first index, let me first of all remove this part. So when I run, you can see like nothing is happening. Like I'm not getting any error. I'm not getting any error there. And then also when I pass in, for example, one, when I pass in, for example, let's say Joy, you can see I'm saying, okay, sorry, I need to, so it is kids, then we're specifying this, the first index here should be, let me run, I don't know if I had run, because, okay, yeah, I was worried. So we are specifying now from the kids. You remember the tuples, right? Guys, do you remember the tuples? We talked about it the other time. Who can tell us, for example, the characteristic of a tuple? Let me see in the chat. Yeah, immutable. Thank you. Another person? All right. So, yeah, it is immutable. And then the person could say, for example, it is ordered. It is, let me see first of all. Okay, yeah. Can store different data types. Yeah, very, very true. Very true. And how is it defined? Yeah, like that. Yeah, true, true. Ordered and changeable allows duplicate define. Yeah. Sakina has nailed it, everything. So this is very good. So now we are assuming that this part is like a variable. This like a tuple. Remember, tuple is defined like a this way, like a this these are parentheses. So it's like we're trying to say, for example, when I add in, for example, here John, John. Essentially, what I mean is like this, like a tuple is going to be to consider it as a tuple, and then it's going to be like a variable. Like is in other words, you could say, for example, you could say, for example, kids, and then you assign it to this a tuple or tuple, whatever name you give it. It's the same thing as this one. So if you want to access, for example, joy, if you wanted to access, for example, joy, which is the first index, then, for example, you could say kids, and then you specify the index because it's ordered, which means that you can access it with their index. So when you say here 0, and then you do the print, you write here the print statement, then you're going to get what you're going to get like at that first index, which is joy. So it's like a similar thing here. It's like a tuple, like the normal variable, and then the values for that tuple. So that to access it, you need to first of all specify the variable, in this case kids, or arguments. We are calling parameters here. Then now you specify the index, so that you get the output. So this is arbitrary argument. So it can take, you can see when I use without, when I use 1, when I use 2, when I use 3, I add in here, for example, James, and then so I still get everything without getting the error. So this one can be very, very useful. For example, if you have it function as a module somewhere else, and then you just want to pass like unlimited number of arguments, then this is how you will go about it. This is how you could go about it. Let me know if you guys have understood the arbitrary arguments. Wonderful. Great. Thank you. So there's something also called the keyword arguments. Like sometimes you don't want like to follow this order, because now remember, when you are doing this way, like when you say first index, when you use like at the first index, then you need to be sure that it is for example, okay, like let me come to this one this way. Like for example, for this one, for you to get the output A and B, so A is going to stand like a for 10, then a B is going to stand for 30. So sometimes you are not sure, for example, what if it's A that begins, or a B follows, or C. I'm using just a simple example with A and B, but then in production, I said that you need to be descriptive. You need to give like a variable name, descriptive names. So you will not be sure, for example, the name has begun. For example, first name, last name, perhaps those could be your arguments in your function. Perhaps could be first name, username, password. You are not sure about. Let me see. You are not sure about. You're not sure about like that order. So Python provides us with a way you can define what you can define like these arguments in keywords. So for example, let's assume that you have name, and then for example, age. So, and then here, let me just say, let me use a formatted string. We talked about it earlier. Remember, you can use capital or small. Let me use small. And then my name is, and then I'll pass here name as a variable inside my string. And I am age years old. So now Now I'm not sure, like for A and B, we were able to predict that A, because when you'll be following the alphabetical order, A could have begun, B followed like that. But then, for example, if you're using names, age, perhaps something else, you want to be sure, for example, if age has begun or name has begun. So we have a way where you can like handle this case so that, because, for example, if you were to run it this way, for example, when you just say, you give it a value. For example, we know that the first argument, our intention was to be, it takes two arguments. But then, for example, let's say we begin with 20 years, and then here we say Joy. So it has taken two arguments. But then now, when you run, okay, sorry, guys, sorry. I mean, we should be calling the function. This is why I'm so stuck to the print statements. Like when you call in the function, you need to use the same function name that you define it with, and then you pass in the arguments if it takes any argument. So now I can say now my name is 20, and I am Joy years old. So you can see now it doesn't make any sense. Doesn't any make any sense. And it doesn't mean that I will have to always go to another module. For example, if it's a package or a module, you go to it and check the order, it's going to waste a lot of time. So Python provides a way where you can like create function in a keyword format, such that in this function, I'll be calling the function. You can like say, for example, this is age. You assign it a value, and then this is a name. Name, you also assign it a value, such that when you'll be calling name and age, even though the order is not a positional, still you'll do what you'll get like the correct format. You get the correct format, like age, it is 20, and then name is Joy. So when you'll be calling it, like it's going to understand. It's going to understand what you're trying to do, what you're trying to do. So this is what we call the keyword arguments. So the keyword arguments, like I just define your variables or parameters very normally, but then for the values, you are going to like assign like a values. Like I define again the variable, you assign it a value, and then like those like variables and then values, such that because you're not sure, because when you just place your values there randomly, like it's going to like take, because it's positional, it's going to like follow that format. But then when you use the keyword, you're able to interchange the order, but still you're going to get the same output. Even though you're trying to interchange on the keyword arguments, still it considers the same number of arguments. So for example, if I wanted to increase, you increase, for example, you're adding another one, for example, nationality, and then you give it, for example, I'm not sure if this is spelling, something like that. So you're going to get an error. You're going to get an error that you got an unexpected keyword arguments. So even though you're using the keyword arguments, so it should tally with the number of parameters you passed here. Like the number of arguments you are passing on the function call, it should be the same number of the arguments you defined on the function definition here. So that's positional. Positional argument. Okay, not positional, actually. It is a keyword arguments. But then when you'll be calling it, you need to do what you need to like place the same number, even though the order is not restricted. Like you don't need to follow a particular order. Even though you're not following that order, you need to remember the number of arguments it takes, the number of arguments you had defined it with so that when you are calling the function, you are using the same number of keyword arguments. So the keyword arguments is similar to how you are doing with how you are trying to do it. How you're using, for example, what do you call it? Like it's like a dictionaries. It's like a dictionary, though we are coming to it. But just consider this one is another way on how you can like assign values to your arguments or parameters without following a particular order. Let me know, guys, if that's clear. If I talk about arbitrary. All right, great. Now, sometimes you also don't want to like get such issues. Don't want to get like this error. For example, when you increase the number, you get this error. Like I can say when you increase, for example, nationality, we are getting this error. So in such a way, for example, if you want to avoid getting such errors, then Python provides us a way on how you can create also arbitrary on the keyword arguments. You can as well create the arbitrary keyword arguments. Okay, first of all, the syntax for keyword arguments is this way. It is, remember this hash is for comment. Then for the keyword arguments, you just write quotes like I did there. The keyword arguments normally. But then, okay, let me see. This arbitrary, and then arguments. Remember, arguments is just one without this static. Sometimes when you run, sometimes there are some other debuggers, it will tell you something like this. So don't worry, it just represent the keyword arguments. And then for the arbitrary, for example, let's say you are creating a function about the kids. Let's still use the kids, children. So children is the function. But then we are not sure about the number of children we have, you have, or I have. So let's use that kids here. But I want to use what the arbitrary keyword argument. So for arbitrary keyword arguments, you need to use 2 asterisk. This is the syntax for arbitrary keyword argument. So which means that it can have as many keyword arguments as you can. So so in this case, for example, I could say, okay, this is just the syntax. Keywords arguments. I hope this is spelling keyword arguments. So you define it this way. You define it this way, and then now when you'll be calling the function, let me just use the same thing because I don't want to repeat rewriting everything. Okay, there was somewhere for children, I think. Okay, let me just use this statement. So remember, you need to end it with the colon. Sorry, you need to end in at the end with a colon like that. You need to end it with what something called a colon. And then now what you do, let's write in our program. So my name is, okay, my name is, okay, so now when you will be calling the functions, let's have this one. When we'll be calling the functions, I want to use it in a different cell. When you'll be calling the function, even though you're using the name, age, okay, age, name, nationality, even though we have defined our arbitrary arguments here in this case, let me first of all run. I will get like this name is undefined. When I run, you can see that, first of all, I'm still getting the arbitrary keyword arguments. First of all, let me so I have this this cell I've run, and then I'm running the second one. So guys, you notice that there's an issue here. I forgot to change. Remember, when you're calling the function, you need to use the same function name. So now you can see that I'm getting a name is not defined. Name is not defined, although on the function call, on the keyword arguments, we are trying to just assign values to it this way. So in this case, we all know that this is a format of which data structure, guys, that is defined with the parentheses. Okay, a tuple, yeah, tuple, true. This is a format of a tuple. So for example, it's like I'm trying to say kids, and then you assign it to this data structure for a tuple. So you can see now it is a tuple still, but then it's storing the values in the key. Okay, the variable value. So in dictionary, we talked about not in dictionary generally, but we talked about the type conversion. So the type conversion, for example, if I want to get the dictionary in this case, which is defined in the key value pair. So we could have said, because for example, normally if it were just a normal tuple, we could pass the value directly in this case, like just values directly. But then because we're interested in the dictionary, we store the values in the key value pair. So in this case, when you print kids, it's going to convert it into a dictionary which is storing the data in the key value pair. Although on the tuple it was age, a variable, and then the value. So when you want, for example, to access this value 20, so let's use a variable a. We'll use kids as our object in this case. But then we say that in a dictionary, don't access elements with the index. Perhaps we say like index 0, and then I pass in what here a, because it is using the keys and values. So in this case, guys, what you need to do, you need to specify the key. For example, you're interested in the age. So you'll be passing what here? You'll be passing the key, of which is a string. You saw the output right somewhere. Okay, I think I should have used the different cell. Let me copy first this one. I'll create a new cell, so that I can remodify this one, so that I can demonstrate. So I'm trying to redo. Okay. So the output, you can see it is in the key value pair. So now, even though we've written this way, just consider that this edge is in a string format. So you need to pass it in a string to access what is the value. So when you pass here a, you'll be able to do what you'll be able to get now the value. So you can see you're able to access the elements by defining their keys, not the index. When you use the index, you'll get the error. So the same approach is here. Like this is like a dictionary, like because the values, we have the keys and the value. The key is like a key and the value, because essentially the thing that we are writing here at the top, remember I told you, are considered as variables. They are parameters, but in the variable context could be like the variable names, and then the information you are passing here, they are arguments, or could be considered as value. So you cannot try to call a value. For example, you say a is you try to say for example b. Okay, a is let's say Nehemiah. We know it's just so we cannot say, for example, print Nehemiah here, because the purpose of variables is to use a variable name instead of the value. So for example, when you try to say here name, it's like you're trying to call a value. It's like you're trying to call a value, because we know this is like a variable, and then this is a value. Now, when you pass here name, just name like that, it means that you're trying to call a value, and we know we should always call the variables. So when you do this way, we'll get this error that is not defined, because it's like you're trying to do what you're trying to call a value. Okay, you're trying to use a value in place of a variable. That's why it will tell you like it's not defined. So you can consider this part as a dictionary, because it's storing information, like it's a variable value, but then because we can't use like two variables, because we have this one as a variable, so we could use it as a dictionary. We have that conversion for tuple to dictionary. Now here you could say, for example, this is like a key, and then this is a value. So if you want to get, for example, this name or age, then you will say kids, and then here you specify what the key, but you'll notice that we're going to get an error. I want to get the error intentionally here. Then I'll think, okay, I'll try. Let me first of all run. When I run, I'm going to get the error. What could be the error, guys? In this case, who can notice the error? Let me see in the chat. Who can notice the? Okay, first of all, let me just convert here to kids. kids, which is this variable, but I'm getting the error. So who has noticed the error? Oh yeah, missing the quotes. That's very true. That's very true because this like are key value pairs. These are like, even though they are tuples, we know the structure of a dictionary. They are in a key value pair. These are in key value pair. So when you want to call a key, you need to give what you need to define it in quotes, because these are not variables. These are like a values. So you need to write it in quotes like this. You need to write it in quotes to get the now the values for those keys. So in this case, you'll be able to do it. You'll be able to get the output without any issue. You'll be able to get the output without any issue. And I've seen that I've included nationality, but I'm not going to get an error. So the arbitrary keyword arguments like allows you to give it as many arguments as you can. For example, you could say, for example, my name is whatever I am, and I could as well add in, for example, I come from then here I'll use kids, and then kids, and then you give it the variable, this key, nationality. Nationality like that. So if everything is okay, then it should include. Okay, sorry. I think I forgot to close it somewhere. Now we have the okay, sorry. So I could say it is I come from. So I forgot to do it. I think there's some error somewhere that I'm missing. Oh yeah, here. Yeah. Let me see. And terminated string later. Wow. So it's bringing another issue. Actually, there should be some. So there's the string, and then it should close, and then I will have this. Let me see. Okay, yeah, and I come from Eritrea. I come from Eritrea. So you can see now we have done what we have, like assign our own arguments, or on the function call we have given out our own like something like variables, so that we can use it as whatever we want to use. So in this one, we are not limited on the number of keywords that you could use. But then, even though you're using this way, you need to consider the initial here, the initial what do you call it, like a parameter, so that when we call the function, we'll be using it as the first item, and then the key data. Let me know if it's clear. All right, thank you so much. Have you understood, guys? The arbitrary keyword arguments. All right, great. Wonderful. You guys are amazing. Just understand at one go. Great. Wonderful. All right. So now before I talk about the classes and objects, I want to quickly talk about the function. Okay, we've talked about the function. I want to quickly talk about the, what do we call it, like a conditional statements. Conditional statements. Call it conditional statements. Basically, we have part of the operators. I couldn't talk about it. Because we were not to go through everything. But in Python, we have operators, and we have different type of operators: the conditional operators, logical operators. We have comparison operators, bitwise operators, and so forth. There are many kind of operators. Like for example, when you say A, we assign it to value 20, you are not equating this value 20 to A. You are basically using an assignment operator, this equal operator. You are assigning 20 to A. You're not equating A to 20. If you wanted to equate, you could use two equal operator. So this is assignment operator, and then comparison operator if it was in the event, for example, you have to use these two equal operator. And then we also have the arithmetic operators like plus, minus, asterisk for multiplication, division, modulus, like that, and then so for exponential and all that. I don't want to go to that operators, but we have some. In this case, I want to talk about the Booleans. I believe we had touched about the Booleans values. And the Booleans values, mostly they use the comparison operators. For example, when you say, for example, 10 equals to 11. Is this statement true? Is this statement true? I know the answer, but I want to get the engagement here. Is this statement true or false? Yeah, false. So it's false. So we are using now the comparison operator in this case to get the output. So you can see now I'm getting false if the statement, we are using the comparison operator to check if this condition is true. For example, 10 is equals to 11. But then for example, when you say 10, is this 10 greater than 11? It's false, right? Yeah, it's false. Yeah, true. But then when I say less than, I'm going to get true. I'm going to get true. Yeah, true, because the condition is met. So basically, other than this basic default true false, like you can have something descriptive, such that if the condition is true, instead of like returning the true, you could have something descriptive. There's something descriptive. I know, guys, that you've ever tried to log into a system, and then, for example, if the passwords and the username are wrong, then I'll do it. You will get you will get, for example, it will prompt, or maybe it will throw an error that password is not correct or username is not available, something like that. So basically, they are just using the conditional statement. For example, if the program or maybe the condition is true, for example, assuming that you're trying to check, because the information that you're trying to pass for you to be authenticated in that system, like the password that you're trying to add, and then the username should resemble what is in the database for you to be authenticated in the system. But then, for example, if the password or the username doesn't match what is in the database, then it will do something else. Perhaps it will give you an error. So you'll want like to implement something like that. And then in this case, you need to use a conditional statement. For example, let's say A will give it something like a 10, then a B will give it 50. B will give it 50. First of all, let me we'll give it okay, I had written some Python code trying to test on class and function. What will be the problem within to the code? Okay, guys, we are coming to the classes in a few. And I will demonstrate. I just want to talk about shortly about the conditional statements and that the loops. Then we are coming to the classes in a few. We are going to cover everything today. So basically, in this case, you'll want, for example, to do some conditional check if it matches the condition. So you could use the if. For example, if A and using the comparison operator greater than, for example, B, and then you need to add in the colon so that the condition that you're trying to check, or a program that will be you will want to execute within this if statement, also it should be within this indentation block, this space, so that it will be considered as it's part of this if statement. So this one is checking if it's true. For example, if A is greater than B, and then you will say, for example, print A is greater than B. So when I run, I'm not getting anything. What could be the reason, guys? When I run, I'm not getting any output. What could be the reason to this? The condition is not met, right? Because A is smaller than, so the condition is not true. Yeah, true. Like this condition is not met, like A is not greater than B, so it's not going to execute this one because it's going to only execute as long as the condition is true. We have not provided an alternative if it's false. So when I write here, for example, 100, 100 will be greater than 50, so it should automatically print out A is greater than B because the condition is met. So if it's not met, when you use now this if statement, it's not going to return the output because at the if, it is strictly checking on the true. If always check for the true, if the condition is true. So if it is true, it's when it's going to execute. Otherwise, you need to implement one for false. Remember, we have only true or binary values, either true or false. So you need to have a way you can implement like a two checks. So if it's not greater than, or maybe if it's not true, you need to have like an alternative. So you could use else. So if A is greater than B, print A is greater than B. If it's not greater than B, then you need to do something else. So I will say, for example, print, 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 and then I will say, for example, um, A, or maybe we could say B is greater than B, or maybe we say A is less than less than B. A is less than B. A is less than B. So for example, when I say, for example, if A is this condition I said it's trying to check like if it's true. So if A is greater than B, it's going to print this one, like it's trying to like check if it's true. If A is really greater than B, and we know A is 10, B is 50, so this condition is not true. So it's not going to return this one. But then now we need to provide another alternative. In the event, for example, if it's not true, what should happen? So else is going to like catch the false, like the false part. So else do something else. So in this case, we're going to say else print A is less than B. A is less than B. And then, for example, if I increase here to 100, so the output is going to be greater than B, because this is the condition that the first condition has to be met. So the first condition has to be met. So I'm getting this output. Now, what about if I use here 50? I'm getting the output as A is less than B. Is this true? Is A really less than B? No. Yeah, no. It is no. But then now our program, we've written something that doesn't make any sense. So we could have like implemented another alternative. For example, if it's not greater than B, and then also if it's not less than B, what should be captured? So Python provides another alternative. For example, remember, first of all, this one is trying to check if it's true. If it's trying to check if the program or maybe the condition is true. So like a Python provides another way before you go to the else. You should, like a Python provides another way to check another condition as well. So apart from if, for example, if it has checked the first condition is not true, then before it goes to the false, you'll provide another alternative called else if. Else if, then you provide another condition. So you could say else if, but then in Python you write elif. Elif is like a else if, then you provide another condition. For example, A is equals to B and then a colon. Then you write here your program, print A is equal to B. A is equals to B. So basically what this program is trying to do, first of all, it is trying to check if A is greater than B. So if it's greater than, if it's not greater than B, okay, first of all, if it's greater than B, then the condition is going to be met, and then it's going to return the output. But then if it is not, A is not less than B, like if this condition has not been met, then you are going to check another condition before you conclude. So before you conclude, try to check something else. So here we're trying to use now elif. Elif is like a else if. So if the first condition is not met, then try something else before you conclude. So here we're trying to use, say, elif A equals to B. So it's trying to check also if A equals to B. A equals to B. So if it's equal to B, then it's going to execute this part. It's going to ignore this part, and then it's going to return this second program if the condition is met. Otherwise, it's going to now execute now the last option. So if it's equal, then it means now this condition has been met. A equals to B. That's why it is returning A equals to B. A equals to B. A equals to B because this condition has been met. Otherwise, you could say, for example, it is going to capture, for example, if it increases, it's going to capture less than, because A is 50, B is 100. So basically A is less than B. So this condition has been met. This one, it wasn't met. This one wasn't met, but this one has been met. Remember else, this one captures anything that hasn't been caught on the if or elif. Now remember elif can be as many as you want, but then we know normally on the comparison for arithmetic, they can either be less than or equal to or greater than. So you have like three options, but then you might have some conditions where you're trying to where you're trying to check like a more than two. A good example, when you go to an e-citizen, for Nigerians, the e-citizen is a platform, it's a government platform where you could go there and maybe access things like ID, apply for ID, visas and all that. So you saw when you try to log in to that system, it has an option. For example, that field when you have created an account, you want to sign in, it has an option. For example, you can either log in with a username, an email, or a phone number. So you can tell in this in that program, you cannot that is trying to like check is trying to, for example, you're trying to say, remember password should be should be unique. But then now on the login, you can either use phone number or email or perhaps the username. So first of all, if it's trying to check, for example, if password and the phone number, for example, if you're using the phone number, if that phone number and the password matches, or maybe username and password or email and password. So like it's trying to take all of them. So first program it could tell, for example, could say, for example, if password, for example, if username combination with password, and then another program we could say, for example, if email and the password, and then another one perhaps else or something else. Perhaps we could say, for example, phone number and the password. So like it's trying to utilize all of these. But then we have the what do you call it? Like the logical operators. The logical operators is like, for example, you want to pay when you use something like and for example, how can I put it? And for example, when you say is either, for example, when you say okay, let me not go into that direction, guys, but I will have the logical operator such that you can combine several conditions. You can try to combine several conditions and check if all of them matches the in this case, actually we are trying to do it. We are trying to only just check on one condition, like if it's greater than B. But then in some cases you might want to say, for example, you're trying to check if it's okay, this is greater than B, greater than simple actually. You were trying to check if A is greater than B, or perhaps sometimes you might also want to check if A is greater than B or equal to B. So like you're trying to combine two conditions to check. So you are using what the and in that case, or those are operators. So guys, I'll give you an assignment. Go learn more about the operators in Python so that you'll understand them more. But then in a nutshell, this is how the conditional statements does. So basically the conditional statement is trying to check if a condition is met. If a condition is met, it's going to return true. If it's not met, it should return false. But then sometimes you might want to have several checks before you conclude to, you go to the else. So this is where you use what the elif. If the first condition is not met, before you conclude, try to check something, another condition. If this other condition is not met, you could have as well have another elif, another elif, something like this. But remember, in this case, we only like on the comparison, we have either less than, equal to, or a greater than. But then I'm just trying to add in here like just to show you how you could use the elif. So you can have as many elif as you want, provided like the condition that you're trying to check are more than the number that you want to utilize on those elif. So basically, the elif is trying to like only execute, or maybe before it go to the conclusion, the else is trying to check first of all if the first condition is met. If it's not met, it's trying to check another condition. If the second condition is not met, it's going to check another condition. If everything is not met, then this is a conclusion. Now the else is trying to like capture everything that wasn't caught up in this if and elif statements. Guys, let me know if that's clear. You've understood? Yes, great. So guys, in a nutshell, that's about the conditional statements. And one last thing, guys, let me talk about the loops. Let me talk about the loops, guys. The loops, let me just create a new file because I think someone will need these notebooks. I'm not sure, but let me just create a new one so that we can organize our work well. I told you when we were introducing Python programming, we said that it's good to be organized. So here I'm going to use give it loops. And basically in Python, we have two primitive loops. Remember loops, in other words, like you're trying to go through it, like it's like iteration. When you're looking through something, it's like you're trying to iterate. To iterate is like you're trying to go through things one by one. Let's say you have a basket of fruits. Now, for you to be able to reach the last fruit in that basket, it means that I will need to first of all remove the fruits at the top for you to be able to reach the very last fruit in that. Like you cannot reach it unless you've gone through these other ones at the top for you to be able to reach like the last fruits in that basket in that case. So the loop is trying to do the same thing. Loops is like, for example, you have this list. First of all, loops work on iterable objects, like the list. In this case, we're using the list, or the tuples, or dictionaries, or what else? Strings as well is an iterable object. So basically, and I remember I told you like in Python, almost everything are like object, are considered object. Python is basically an object-oriented programming, like literally almost everything is like an object in Python. So when I say string is like an object, I mean like just know that I'm talking about the strings, but I will talk about the classes and objects to understand more. But in Python, almost everything are like objects. So when I say, for example, any triple object, it's like anything that stores more than one item. For example, the list you can see stores more than one element or item. The tuples as well, we talked about the other time, it stores like more than one, it's like a collection. The dictionary as well, and the sets. And also the strings. The strings, they also stores characters. We said that elements in a string are those characters. So remember slicing. We're able to slice a string as well. I don't know if it was this class, but we could as well access the characters in a string by referring to their index number. I'm not sure if it is this class, but then let's just quickly show you. For example, let me have Nehemiah as a string, just a normal string. I'm sorry to use my name. My name is Nehemiah, forgive me for that. And then, for example, if I wanted to access the first index here, I could say, for example, B, and then I'll assign here to A, but then I'll target what? The first index, which is A. So when you say print, okay, the first index is 0, sorry, not A. Sorry. So, okay, sorry. I should be B, I should print out B. So it's going to return now A. So you can now notice that it is like each element have their own index. So their string is also an iterable object. Like each character now there are its elements. In a list, the elements, these items here, they are now elements. But then in a string, each character are the elements of this string object. We call it objects. But then, so it's an iterable object, like it stores more than one item. So now in this list, for example, to go through it, we can use a loop. We can use a for loop. For, then you give it a new variable. For example, to stand for individual item, for example, fruit. And first of all, remember, and then we have an operator here in the membership operator. Guys, I give you an assignment to go and learn more about the operators in Python. The logical operator, arithmetic operators, the membership operators, the bytetrace. No, don't learn about the bytetrace. You will rarely use it. Learn about the comparison operators, arithmetic operators, logical operators, comparison operators. Those are the key operators in Python that you should learn. So I'm trying to use the fruit as my new variable in. So I'm trying to check this fruit in my fruits. And something about the, okay, then let me say print. First of all, let me print and I'm going to explain. When I say print fruit, when I say, I'll say fruit, then it's going to like return this output. Now, let me try to explain. I say that, for example, when you have something like A, okay, A, you give it a value. Then I say Python is variables are dynamic. And then, for example, you give a new value to A, for example, 30. Then you say print. So what will be the new value before you run the output? What will be the value for A when I run? In this case, when you just check it. Yeah, it is 30. It is 30 because it is dynamic. It is dynamic. Like Python usually execute code line by line. So it's going to like, because it's dynamic, so it's going to like, first of all, check on this one, try to run now. Before it goes to the next one, now you can see now the A, it's updated to 30. So now it's going to return now 30 because this is the new value that we have reassigned to A. So Python is dynamic. Now, let me show you how we are getting this output mango, purple, and orange. First of all, consider that iterations like you're trying to go through elements, like you're trying to iterate over your object, in this case, a list. So when you say for fruit, remember, anytime you use a for, just consider that you are trying to go through something. In this case, we are trying to go through this list. Now, when we say for fruit, remember fruit is just like a new variable data. We are assigning for individual element when we are trying to go through it. Like consider, let's try to imagine that your hand is, let me use X. Let's call our hand X. And then the basket of fruits, we could call it fruits. Like let's just call it fruits in our basket. Now, when you hold the first fruit, remember the target we want to access what the last fruit in our basket. Now, when you hold the first fruit in this case is mango. At that time, let's call your hand X, right? Let's call your hand X. So it has done what? It has hold that mango fruit. But then now when you remove and you put it down, and then you go and pick the second fruit. Now it is holding like a new fruit which is purple, but the hand is still the same, right? It's like the variables. It is still the same. It is the same hand, but you have done what you have like you selected a different fruit. Then when you go and pick another fruit, then at that time your hand is still X, but the fruit has done what has changed. Now, when you reach the last one, you have done what? the hand is still in our case we are calling it X. Our hand is X, but then the fruit has done what has changed. So it's similar to variable because we said they are dynamic. Like if the variable is the same, but then you give it a new value, at that time it's going to use that value. When you change to a new value, in this case, because we are trying to go through it, when you give it, for example, purple, when you reach to purple, at that time the value for X is going to be purple. And then when you reach to orange, the hand is still the same, X, we call it X, but then the value has changed to orange. So these are variable. We talked about it being dynamic. I don't know why I deleted the cell, but then before you reach the very end, so the very last fruit is going to do what? Is going to be grapes. But then, as it tries to iterate over it, we are trying to print. We are trying to print, like for example, for X in fruits, remember 4 is essentially iteration. So when you say for X in fruits, so when you reach to mango, we are printing. When we reach to mango, we are printing. And then when you go to the next one, which at that time your new variable, it will be X. When you reach at it, okay, sorry guys, here should be X. I'm talking about X because we've changed here the variable. It should be X. We are basically trying to print like this, our hand. In our case, we are calling our hand X. Now, when you hold this mango in our fruits, then we at the same time want to print. Okay, to print. We are trying to print like when you reach to mango, we are printing. Now, when you go to the next one, we know our next item is going to be purple. When you reach at it, again, we are trying to do what we are trying to print. When you reach to orange, we are trying to do what we are trying as well to print. That's why you see before we reach the very last one, we have received the all these output. Now, when you try to do it, okay, let's say, let me try something here. Don't know if there's X somewhere at the top when say print. Print X. So you can see now when I print here X, it means that at that time, the X is grapes. It is grapes because now you can see this is in a new line, right? This is a new line, which means that the very last item, because a Python is dynamic, so it means that it's going to take like at the very last item to store like to be stored in that variable. And that variable, when you use it in a new line, it means that you're only focusing on the very updated value of your X. In this case, it has returned now grapes because it's the very last item. But then now when you use the print inside this loop, it means that when you're iterating over it, you want at the same time to get the output. So anytime you find an X, value for an X, you need to print it out. So before you reach the very last one, then you will have done what you will have like returned all the elements in that iterable object. I don't know, guys, if you've understood that. Should I repeat? Or you've understood? Let me know if you've understood, guys. If it's clear, great. Great. So I said in Python we have two primitive loops. We have this for loop, but then we also have another one called while loops. And guys, I don't encourage anyone to use the while loops because this one you need to be very, very sensitive whenever you're working with it. Because if the condition is not going to be met, but guys, let me show you how this system is going to, like in this computer, the RAM for the computer is I think that it was something like that. GB, but then the memory is going to be depleted and that this machine is going to crack here, like it's going to crash. Let me show you how I can crash this computer with just like a simple program here. So let me initialize my program. Let me use I. I'm going to give it something like 0. Perhaps let me give it 1. Then, and then let me use while. For example, let me say I is less than whatever number, like a 10, then print. Guys, I'm going to, like the system is going to crash here. And I want to do it intentionally so that you see how serious these things are. Now, when I run, it's going to have here an infinite loop. Let me just run it, and then I think I'll also be disconnected in the call. But then let's just, because I want to intentionally do it so that I can demonstrate something. So this computer is going to crash, or the memory is going to be depleted in a few. And I want to do it intentionally so that you can know the risk whenever you're using this loop. In fact, I can't even scroll. If I give it some few minutes, then my memory is going to be depleted here, and it is. I think it has a lot of memory here. 32 GB. I think it's too big, but then it's going to be depleted here. And you can see at this part time, I cannot do anything here. When I try to click here, it's not going to work. You know, I don't want it to go until the system crash. Let me see if I can do it. I can undo. Let me see if I can refresh. If I could give it some few minutes, you'll notice that the system is going to crash, and I don't want to do that because I'll be disconnected in the call. Let me see. Let me first of all, let me say while I is less than, for example, at 10, we say print I. So who can tell me the reason is try got an infinite loop in this case? Who can tell me? Okay, let's try to put this in this context. Now, when you say while I is less than 10, it means that as long as, in other words, it means like as long as I is less than 10, print I. So we know that there's no point. You can know in our case I is what? I is 1. So that we know that forever. I don't know if it will reach a point and it will change, but we know there's no point at the moment where I will come to be greater than it, because unless it is greater than 10, it's where this condition is not going to work, because it's like you're trying to use this while is somehow related to the conditional statement, like at the if statement. Like, for example, if the statement is true, it's trying to execute something. So the while, in other words, it means like as long as I is less than 10, then it's going to print. So it's going to like a print I until the day when one is going to be greater than 10. And we know it's going to be difficult, right? There's no point in future where one is going to be bigger than 10. So it's going to run until the day when one will be greater than 10, so that it will not continue to execute. That's why it's going to have like an infinite loop. And guys, if you'll be deploying the projects, they're using such thing where you have like infinite loops. You'll find out, for example, if you deploy in platform where you pay depending on the resources you use. For example, if you deployed on AWS, you might find out within a month, your bill is, you need to pay $1 million, $1 million, and you don't have anything. Perhaps the database doesn't have anything, or like I just have like a simple application, but then you find that you're using a lot of resources. Remember, when you are running, you're using you're using the resources. In this case, I'm using my. Okay, guys, I'm not sure if I'm still in the meeting. Actually, my system crashed. I don't know if I'm still in the call.
Yes, you're
Hello.
still in the call. You're still in the call. We can still see
Okay,
your.
thank you so much. Yeah. So guys, you notice that you might have a program that is taking like it is utilizing. If I could give that program to run forever, for some time, in fact, like 1 minute, you'll find out that my 32 GB RAM is depleted. It is depleted for just a very simple program that I've written here, you know. So whenever you're using this thing, that's why I don't recommend people to use the while, unless you know what you're trying to do, like you basically know what you are trying to do. So in this case, guys, for example, you're using the while loop, you could want, for example, to increment. For example, as long as, or maybe while I is greater than I, then you'll want it to increment. So you'll be updating the values of I. So we have another operator, arithmetic operators as well. But then now for increment operators, what do we call it? Like the increment operator, such that, for example, once it has printed out 1, so it should go to the next the next thing, so that instead of going to 1 forever, instead of it returning 1 continuously, then it should do what? It should increment. So first of all, let me put it this way. Let me begin in a simple way. For example, when you say 10, okay, let's say A, we give it 10 value. Then we come and say, for example, A, we're using the increment operator here, A plus what? Plus, for example, 20. In this case, in other words, it means that once you have 10, you want to increase also to add in another value of. So we know that variables are normally dynamic, as we demonstrated earlier, but then the operator that we're using here is not assignment. This is an increment operator. We're using plus and equal. So the output, it will be an increment value of 10 plus 20. 10 plus 20. So when you run here A, okay, I think the system is misbehaving because of that program that we wrote earlier. I need to restart the kernel, and then let me retry. I don't know. Yeah, so I'm getting now this 30 because I'm using this increment operator. So 10, but then I'm using plus equals to 20. So I'm using the increment operator. If I wanted to use the decrement, then I will need to use minus like that and so forth. For multiplication, you'll use the asterisk division, is it forward slash or backslash, forward slash and so forth. So this is in operators. Guys, I encourage you guys to learn more about the operators so that you know how it works. So basically in this case, because we're working with numbers and we don't want to have an infinite loop, then instead of just printing out I, we know normally on the for loop we were saying X and then we are printing X. So when you try to do the same thing here, we'll have what? We'll have an infinite loop. So basically in this case, you'll want to do what? You want to have an increment. Like once you have printed I, then you need to, before it goes to the next value, where I, you need to increment. So in this case, we are going to use I, and then we are going to increment plus 1, or whatever value that you'll want to use to increment. So like, for example, if I is less than 10, so when you print I, so before you go to the next number, you want to always increment. And we know that whenever you use a loop, like you're trying to go through elements. So until you reach a point where I is less than, okay, I is greater than 10, that's where the iteration is going to stop, or maybe the loop is going to stop. So in this case, we can see now it's now returning 1, 2, 3, 4 to 9 until when I is less than 10. So we're using these are increment operator. I've used just numbers, but then it could be, for example, a list or whatever it is. But then in most cases, I'll encourage people to use the for loop. Unless you are sure on what you are doing, don't use this while, because if you don't do it well, you might get many issues. Guys, let me know if you've understood.
Mr. Nehemiah?
Yes, yes.
This is 3:53, so my just we're rounding up now.
Oh, okay. All right. So, guys, have you understood? All right. So yeah. So, guys, I think but I believe it's better for people to understand. Now, guys, I think now because of time, we'll have another class for the final one for for classes and objects, then we'll be trying to do something. We'll try to create some algorithm. We'll talk about the algorithms and the big O notation. The big O notation is just a terminology to use to explain like a work. Sometimes, let's say, we say that there are several ways on how you can achieve something. For example, let's say you wanted to print, for example, A plus B. One way, for example, was to just write in the print statement, for example, print A. Okay, like for example, if it's numbers, let's have okay, like for example, if you wanted to print, for example, 10 plus 20, okay, 20, you could have done this directly within the print statement, or sometimes you could want to use it in the form of a variable A. Okay, you give it 10, then a B, you give it 20, 20, then here just pass here A plus B, and then you get the output. Or sometimes you might want to do the same operation, but then now within a function, somewhere there's somewhere where we talked about it, like where you can use it in, like this was multiplication. So you can see all these processes, we are going to get the same output. So it reaches a point, apart from like solving a problem, and by thereafter this program will be doing such things. Like apart from solving a problem, you want to make sure that the time that it's going to take to solve that problem is very small, and then the resources that it's going to take before it solve that problem is also, it's not too much. I believe you've ever come across systems where, for example, it's an e-commerce, you want to access the product, you'll find that it's going to load forever, or maybe for a long time before it displays the data. Even though it's displaying the data, you've written like a good program to work on that, like to display the data, but then you notice that the time that it has took is too long, and then also the resources that it has taken for it to like return that program is also long. So on the algorithms, we'll be talking about on how you can address such issues. Whenever you're creating the algorithm, apart from just solving the solution, we'll be trying to check on which or maybe what way will you be considering. For example, you'll be checking on the time complexity, and also the time and also the resources that the algorithm is going to do. So that's the big annotation that I will be talking about that. And then also we'll be trying to like solve some small problems. So from tomorrow, it will not be this A, B, C, D. We'll be trying to like create some algorithm, for example, some symbol calculator, or those kind of things, like some small mini projects, so that you know how we can utilize these things. So first of all, we begin with the classes and objects, and then we'll also explain we'll also work on some projects, mini projects, and then we'll talk about the big O notation, and then we'll be done with Python fully. And then day after that, we'll talk about now the machine learning packages. Machine learning package, we'll talk essentially about the data science packages, including the machine learning packages, deep learning packages or libraries. And then as we progress, then after that, we'll talk about now Git and GitHub. Git and GitHub, so that you know how to work with the version control tools as we progress. So guys, I always try like to take it short, but I don't know why I usually take a lot of time, because I usually put myself as a beginner, so I want to like explain everything. But then guys, I'm sure tomorrow we'll finish. I hope you've learned something. So guys, let me know if there's a question up to where we are before I hand it over.
So I would try to like unmute everybody now so that you guys can have access to talk. If you have a question, kindly indicate in the comment section that you have a question, so that I can actually call you while you ask your question. Does anyone have any question? Okay, I'll take that as no one has a question. I hope you guys understood everything that he has explained so far. I knew that you talked about functions, you talked about loops. While talking about loops, you guys branched into tuples. You guys talked about tuples yesterday, day before yesterday, and we saw tuples in play again today. You talk about conditional statements, the if else, multiple conditions in one statement. Um, I mean, I was also following the class. Multiple conditions in one statement, looping, how your computer can crash once you actually run some certain loops. Yeah, so it's been a lot. Thank you very much, Mr. Nehemiah. So, like I said, there is an assignment in the Telegram channel. You can check in the Telegram channel. Make sure you react to the. Samuel, do you have a question? Samuel Alua. So you can check the Telegram channel to see the assignment so that you can do it. I'm yet to send the form for assignment submission, but I would send it probably tomorrow morning. I'll send the slide for this. Mr. Nehemiah, you sent me some files. IPNY does something. I didn't share it in the community. Am I supposed to share it?
So basically, those were the not like I can see the file or maybe the notebooks that I've been writing today. So those are the programs that we were to share, so that they can have what I've been doing. But there's no problem because there was a recording. But there is a good practice to write codes by themselves, people to try to code by themselves. But that was just for their reference in case they wanted to see my code that I was using. Otherwise, the recording was provided. They can just write their own code, the
Oh,
notebook files.
okay, great. Yes, guys. So today is day 6. Yesterday was supposed to be day 5, but we couldn't hold day 5 because of Mr. Nehemiah has some light issues at his end. So I don't know if, because this is after today, we still have. Sorry about that. So yeah, so Mr. Nehemiah had some light issues. So I am. We are supposed to take 10 days. Today is day 6. We have tomorrow. That's Thursday, Friday, Saturday, and upper Monday left for this class. So yeah, those are the 4 days left, and we'll be finishing on that Monday. Or basically, if you guys would vote for us to actually still go ahead and do Tuesday also, right? So I don't know yet, but as we progress, we'll know. So thank you guys for joining. Tomorrow is another day for us to meet. The same time, the same link, the same venue. Yeah. If you have any question, if you need any clarity, make sure to ask in the community. Mr. Nehemiah is also within the community and is ready to answer your questions. So that'll be all for today. Thank you guys for joining. Again, I'll see you in tomorrow's class. Bye everyone.